Hey, what's going on? In this lesson, we're going to talk about pagination for APIs. We're going to talk about a couple of different approaches, why you might want to page your data at all, and then what it's going to look like from the client's perspective, the different approaches to consuming a paginated API. Now, before we get started, I want to mention I have a link to the notes, which will have all the information we talk about here with references, resources, as well as examples. So you should definitely check that out. We'll have a link down below. This is also part of a larger API and backend playlist, so I'll have a link for that playlist too. So first off, what is pagination? And why would you want to do it? So let's say we have 10,000 elements. And let's say we want to retrieve this data from an API. The default behavior may be to select all 10,000 of those elements and send that to the user. Well, what this is going to do is, one, put a lot of effort on the database to retrieve all of that data. And two, when we send that over the line to the client, we have to send a lot of data. This is ultimately going to slow down the response from the API because the amount of data is so large. So what we could do instead is we could split this up into pages, let's say groups of 100. We send that to the client, and most of the time that's going to be enough, as the times you go from page 1 to page 2 to page 3 is quite small actually. So most of the visits will be on these first pages. I mean, just think about it with a Google search. How often do you go to page 2 of Google? You know, maybe that's 10% of the time or something like that. And then from there, 10% of the time you'll go to page 3. So almost all of that data is not even going to be needed. Now, you have to think about how the client might use this paginated API, because if they do need all of this data for some reason, now they're going to have to make tons of requests, grabbing the data 100 at a time. So we also don't want to up the request count too much. So that's one of the potential trade-offs. If you reduce the page size, you're going to get more requests to the server for more data. So you have to think of the ideal page size. How many elements do you want to return? And is this something that you can configure from the client? Those are things you need to consider when you're designing your API. And this might be something that's not universal across all of your different resources in your API. There might be certain ones where you adjust the default page size for that use case. If in many scenarios, the user is going to work through a lot of this data, you can just create a custom endpoint appropriate for whatever the use case is. I mean, you could think of an example like this where we might have some campaigns or something, and you could page it, or you could just have a custom endpoint like /all if you know you have a web page where you need to display all of those values. That might be okay for some things, but for others, it's just not going to work. I mean, think of like YouTube. They couldn't just grab all of the comments in a single query. So most of the time, we're going to concern ourselves with paging and then the appropriate page size for the client. So we're going to talk about some of those things now. So first, let's talk about the API structure for a paginated API endpoint. And this is one of the reasons I recommended nesting your data in some attribute. Let's just say that attribute is data. And then we have our data here inside of an array. And having it in this kind of structure allows us to easily add in other attributes here that can be used for paging through the data. So then the client knows if they want to access the data, they just go into the data attribute. If they want to access paging data, they can grab whatever else, such as .next. So what kind of attributes would we put in here? This is going to depend on your approach to pagination. We're going to talk about a couple of different approaches, but just to get us started, I'll show you an example. We may have something like the count, which is the total number of elements. We may have, for ease to the client, a next attribute, which could be a URL to the next page, and then a similar thing for the previous page. So the consumer of this API can navigate very easily just grabbing those attributes. But we can customize this behavior. We can do whatever structure we want as long as the client knows how to take this information and go to the next page. So let's now talk about the types of pagination. Now we're going to cover two main classifications, with the first classification having kind of two different approaches. So we will talk about offset based and we will talk about cursor based. These are two different approaches with different pros and cons. Sometimes you'll have a business decision that will force a certain one of these. Other times you can choose between the two. So we'll talk about when you have to use a certain one of these. So first let's talk about offset-based pagination. This will use a page attribute, or it will use an offset and a limit. These are basically two different approaches or two ways of describing the same capability. So we're going to first take a look at just working with a page number. Then we'll talk about how to customize it a bit with an offset and a limit. After we go over offset-based, we will then circle back and look at cursor-based pagination. So let's say we have an endpoint / comments, and then you use a URL parameter such as page, and then specify a value such as 3. This request will be sent to our backend, and the backend is going to have some attribute, page size. Let's just say it's a default of 20. Now, how you split up the data is totally up to you in this situation. I'm going to do it by ID, but you could sort it in any way. IDs are very easy to think about because they're numbered, but you could sort by any column. So let's take a look at what page 1 might look like. That would be IDs 1 through 20. Page 2 would be 21 through 40. And then page 3 would be 41 through 60. So by specifying page 3, we would retrieve this data. And then inside of our API endpoint, we would have a next attribute pointing to the next page, and it would just be the same URL, but with a page equal to 4. So really simple for the URL navigation, by far the easiest for the client to understand. And then a previous would just be page 2. So the question then is, how do we go from a number here to an actual database query? Let's write up what this query might look like. So if the page is 3, we could have select everything from whatever table, let's say comments, order by ID or comment ID, and then we can pass to the database a limit. This is going to be the set page size, so 20, how many elements per page, and then we will provide an offset, which is how many rows to skip. So I think we mentioned page 1 was 1 through 20, then page 2 was 21 through 40, and then page 3 was 41 through 60. So if we wanted to jump to page 3 of our data, we would use an offset of 40. Now the important thing to understand here is that this is going to start with the 41st row. So this does not have knowledge of the actual ID value. This is going off of row counts. It just so happens that we have a perfectly sequential number from 1 all the way up through 40. So that's our first approach, really, is just taking a page from the client and converting it to some query. But you'll see here we have this limit and offset. We're really just translating that page number into values here. We could just expose these two things to the client and allow them to provide arbitrary values for these. And that'll be very similar to the page structure. It's just a little bit more exposed to the client. Even before jumping to that approach, though, you can give customization to the client. So for example, you could allow them to provide a page size as a URL parameter, and then that could change the query to something else using this value for the limit and also the math to adjust the offset. So you can think of the offset as just the page minus 1 times the page size. So for example, to get the value 40 from our previous example, we had page 3 3 minus 1 is 2. And then 2 times the page size. By default, it was 20. So that gives us 40. So it's a really simple operation to go from a page number to the appropriate offset. So if we wanted to allow these to be provided from the user, we might get something like /comments and then a query parameter limit being equal to, say, 30 and an offset of 120. And now we don't have specific page numbers. Instead, we just have these values, which are then translated to grabbing a certain number of rows from the database. And this is really simple. We just pass this directly to the database. Limit 30, offset 120. Now be sure to do any kind of parameterization or filtering so we don't get any SQL injection attacks. But that's basically what we're doing. We just substitute those values in directly. Then the database just grabs the appropriate rows. So the page idea and the limit and the offset idea are the same thing behind the scenes. It's just changing how the user interacts with the API. The next attribute would look something like this. Comments, limit 30, and offset 150. So basically just adding the limit to that previous offset to get the next URL. And then the client can easily click this if they're within an API viewer, or just grab that in code and navigate to that path to get the next page of data. Same idea with the previous, you would just subtract instead of add. So I kind of like this approach because it gives control to the client, but you can still set boundaries on the back end. So you could say there's a max limit so they don't just grab all of the data. So if you went in here and put 3,000, maybe it would default to, a max of 150 or something. But it does give the client more control, and you can have a drop down that says elements per page, and maybe you have 20, 50, 100, so that they can choose the appropriate one for whatever they're trying to do. So what are some of the big downsides of this? Well, the big one is that this offset is row-based. It has no concept of the data or which element it is at. It's just a number that represents how far off we are from the start of that data set. So I should say something like row number based. What this means is if the data changes as you are navigating through the pages, you could get gaps or repeating values that show up. Let's just show a very simple example of this. So here we have 10 elements, and let's say we're getting 3 at a time. So we're looking at these 3. The offset here is 3. And now let's say we want to go to the next page, but some data was deleted. So let's say we have 1, 2, 5, 6, 7, 8, 9, and 10. We go from an offset of 3 to an offset of 6 to go to the next page. So 1, 2, 3, 4, 5, 6, and we start here. And we go all the way to the end because we're out of data, or you could think of this as grabbing 11 as well. So we basically just skipped over 7 and 8 because we're using an offset. So basically anytime we add or remove data earlier on in our data set, that's going to shift where we start. And if we're having that happen as we're navigating through the pages, that's a pretty disruptive experience for the user. So now I want to talk about cursor-based. And you can think of this as using a cursor or pointer to the last record seen. And this will pretty much ignore any deletes or new data because it doesn't use an offset. You can think of it as just identifying a specific row and then going from there. So going back to that previous example, so let's say the first page had 1, 2, 3, and then we go to the next page and we grab 4, 5, and 6. And then some data is deleted, so it goes 1, 2, 5, 6, 7, 8, 9, and 10. Well, the cursor is basically going to say, hey, this was our last scene. So this is where we're going to continue from, and then we'll go to 7. So we're able to grab that next set of data. So in this situation, we are immune to data being added or removed. But there are a few gotchas here that you definitely need to be aware of. I'm going to talk about some of the pros and cons and when you can and cannot use cursor-based pagination. But first I want to show you what the actual API response might look like. So to navigate to a page, you might see something like this. Comments, and then we'll start with this. We'll say after ID and then some value. And then basically the backend can use that value to know where to start. And then if we had an API response with a next attribute, so it might be something like comments after ID 1, 2, 3, 7, 8, or whatever it may be. So in this situation, we're still using a transparent URL where the value can be seen and interpreted by the client. In other words, they know what ID we're starting at. And generally, this is considered bad practice. We don't want to expose too much here. And it's also very limiting. So here's some of the reasons. Risk of bad exposure, sharing too much information about the database structure and what rows exist. Limited use. In this case, it's tied to an ID. It's also confusing for the direction because we're saying after, which assumes, we're only going forward. So usually all of this stuff is just hidden from the client, and instead we're given a token. This may be called a continuation token or something of that nature, which basically encodes this information. You might be able to decode it, so it's not life or death. It's not like a secret key or something. But basically, instead of having after ID 1, 2, 3, 4, 5, we might have something a little bit more vague, such as continuation and then some value. And this doesn't tie us into a certain column or ordering or anything like that. We can change the behind the scenes implementation if needed, but the way to interact with the API stays the same. So it's pretty common to see continuation tokens, but the same limitations and behaviors apply. So let's talk about some of the limitations of this structure. But before we erase all of this, you can imagine this value being used in an SQL statement where ID is greater than 1, 2, 3, 7, 8. So it goes by the actual ID value and continues from there. With the continuation token, it'll be very important for you to set the next attribute since the client is probably not going to be able to type in arbitrary values or calculate it. You'll just provide what value to use next for the next set of data. So it's a little bit more complicated in setup and understanding from the client, but it does have some of those benefits. When data is added or removed, you're not going to have that shift and then you see some repeating data or skipped data. So let's talk about some of the limitations, some of the reasons why you would not want to do this. So it's going to be limited to certain columns. Basically, you can think of many of the same attributes of a good primary key. It's going to be unique. Since we need to be able to uniquely identify it, it will have to be not null, unchanging, and we will want it to be indexed to get the most performance here. So two good examples would be an ID or a creation timestamp. Because this isn't going to be null, it's something you could index by, it's unique. Most likely if you're not creating multiple at the same exact time. It's unchanging, and you can sort by that very easily. So it could be something like the latest comments. So this is something to keep in mind because with the previous pagination, it's very nice to use for arbitrary filtering and querying. So if you have a big data set, I think I used in an earlier video the example of a car database, and you want to sort and filter by make, model, price, all of these different attributes, that's where a paging system could be quite nice because we're not limited to some of these things with continuation tokens. And this is a big one, depending on if you need this or not. You're not going to be able to do arbitrary page jumps. It's pretty much just next and previous. Visually, you can think of this almost like a linked list. So you might have some page of data you're looking at, and altogether you think of this as the page, the previous pointer, and the next pointer, meaning you can't just jump 7 pages forward like you could with the previous example. So what that means is client side, if you want your current page 17 and then you have the option to click 16 and 15, and then we might have 18 and 19, this is not ideal for this type of pagination. Now, it's technically possible you could manipulate this. So for example, you might have page 17, and then if the user clicked page 19, you could just go to the next pointer twice, but it's just not natural. It's like forcing it. So if you want the user to be able to say, hey, yeah, I want page 36, then you're going to want to go with the offset approach. Or if you want this to be sorted by some arbitrary column, then you will want to go with the offset approach. So client side, the way you would use this is at the bottom of the page, you could have a load more, or you can have an infinite scroll, meaning once you go to the bottom, it will just automatically load the next page. This is the perfect way to consume a cursor-based paginated API. Now, one last thing to mention with the cursor-based approach is that it's the ideal choice for large data sets. So when you're using an offset, the database still has to do some work to jump that offset. You can think of it as just burning through all of those rows to get to where you're trying to go. But if you're working with a specific ID, the database is able to just jump to the proper location. So this is a much more friendly option for very large data sets, because in theory, every time you go an additional page on a regular offset-based pagination-based API, the query is going to take just a little bit longer and a little bit longer until you're way deep into the records and you have a very large offset and you're wasting compute power by not using the database in the most ideal way. This usually isn't a problem for medium to, regular size data sets, but it is something to consider if you are working with large data. So let's take a look at these approaches from the client's point of view. And I want you to think of the options of having multiple pages, like we talked about earlier. If you're going to go this route, you pretty much want to use that offset because the user can provide an arbitrary page. Likely in the URL, you're going to see something like page or offset that you can just provide a value for, and clicking these buttons just makes it easier. For the option of a load more or an infinite scroll, there's one thing I wanted to call out. I think you can do this approach with either of these, because basically with an offset-based approach, you could just load the next page and append that data. But the problem is if you have a current viewed data set, so this is the stuff on the page, it's already loaded in memory. What happens if we click load more, but before we clicked load more, data was added or removed that affects that offset? This could cause duplicate values in the view set. So let's go through a quick example. We're going to list some comments, and let's say we are looking at these 3. So these are added to our comments state, and then we add some data that affects the data that's being retrieved. This could shift the pages. So we were originally looking at 3. When we want to grab the next set of data to append it to our local state, it's going to grab from here. So you can see it crosses over this love it example twice. Additionally, this new comment is skipped over, which isn't probably the end of the world, but our current state is going to look like, hey, great videos, love it, a second instance of love it, and then not bad. This would be avoided with a continuation token because that wouldn't have shifted with the insert of a new comment. So basically what you need to do is if you're appending to a local state, you need to deduplicate, get rid of any duplicate data so the visual doesn't show repeating values. Now this is all just talking about the local state. If you do a refresh, you're not going to have duplicate data. I'm talking about adjusting the state on the page as we go with data being changed on the back end. With a continuation token, this will be a seamless experience. You can just extend the state every time you load more. You're never going to have to worry about the duplicate data showing up. And then data such as this one, this great stuff that was added later, you can just ignore that as you extend the page. And then if you do a refresh, it'll be retrieved fresh. That's all I have in this lesson, which was your introduction to pagination and some of the different approaches. The next logical thing for you to do would be to implement this in some library. So build a backend, create multiple pages, and then if you want, you can learn to consume that on the client end as well. Thank you so much for watching. Hopefully these API videos have been really helpful. If so, please let me know. Or if there's some other topics you'd like me to discuss, leave a comment so I can adjust what type of material to focus on. Thank you so much for watching, and I will see you in the next one. Peace out.